Hello everyone. In this video, we're going to dive into more details working with arrays. For example, how do we print arrays? How can we see what the elements are at each position in an array? How can we compute the minimum, the maximum, or the average of the values in an array? And how can we search an array looking to see if a particular element is in the array? All of these examples that I just mentioned to you are very common array operations that we will have to write loops in order to solve. But that's all right because we are really great loop coders. So we're just going to apply what we've already learned related to while and for loops in order to solve these problems. We're also going to learn a new looping strategy called the for each loop, and we'll see how it can be really useful when working with arrays. All right, so for our warm-up task, let's go ahead and open a file called arrayloopingfun.cpp in gedit and code up an empty main function. All right, in array looping fun, I've already got a task for you to work on. Go ahead and declare an array of 5 integers. Just set each integer to be any number. Just make up some numbers. I don't really care what the integers are as long as they're all slightly different. All right, here's an array of 5 integers, 4, 2, 7, 5, -2, just some random numbers I made up at the top of my head. Now, what we want to do is print out these numbers. How do we see what the contents of an array are? Your initial thought would probably be to do something like this. But this gives really strange output, like really strange. What are all these numbers? Well, all of these numbers represent the starting memory address of the array. Let's write that out. So I mentioned previously that if we have, say, 5 elements in an array, like we have in our numbers example, we don't have one variable for each element of the array. That would be awful. Imagine if our array was 10,000 integers and we had to have 10,000 variables, one in order to access each value. That would be terrible. We wouldn't want to do that. That's the nice thing about arrays. We can have one variable that we can specify indices in order to grab elements from. Now, those indices mean something special in relation to this memory address that we're seeing. So the memory address we're seeing is actually a value in something called hexadecimal base 16 system. Our decimal system that we count from, say, 1 to 10 in is called a decimal system. It's base 10. Hexadecimal is base 16. So it uses 0 through 9 and A through F in order to denote numbers. The 0x in front of the output, right here, denotes that this number is in base 16, hexadecimal. So when you specify an index into an array, that index is multiplied by the size of each memory location in the array, and then added to this number in order to figure out where that variable location is. Note that we don't have to use a variable, as in some kind of identifier in C++ to access it, because of this cool offset arithmetic. So let me show this in a little bit more detail. just made up 5 more integers as part of this array and labeled the valid indices of the array. Now, we won't work with hexadecimal values in this example just because we haven't learned how to even use base 16 or any other base than 10 in this class, but we can still see how offsets work using just standard decimal values. So let's say that integers are 4 bytes large. They typically are on most systems. Then let's say that this array is called nums, and we see out nums. And this prints something like 1,000. Okay? It would be a hexadecimal number, but let's just say it's a decimal number, 1,000. That means that the 5 is located at memory address 1,000. Since integers are 4 bytes large, the -7 is at 1004. The definition of an array is a sequence of items that are contiguously stored in memory. This is why they have to be contiguously stored in memory, because the compiler, when you go to do something like cout nums sub 1, the compiler takes this nums sub 1 and says, okay, this is 1,000 plus 1 times the size of an integer, which is 1004. It goes to the address 1004 in memory and grabs the value there, and that's what's printed out when you say num sub 1. So let's carry on. Num sub 2 would be at location 1008, num sub 3, location 1012, and num sub 4, location 1016. Now, knowing this, if the compiler was trying to give a value for nums sub 2, how would that be computed? It would be the starting address of the array, which is given simply by nums, plus 2 times size of int, which 2 times 4 is 8, would give 1008. And we check, it does match our diagram. All right, so this is all really interesting. If you want to learn more about how memory is organized, take a look at any computer architecture and organization class or book, or stay tuned and take a computer engineering CPEN class here at Gonzaga, and you can learn more about this. All right, let's move on. So all that aside related to memory addresses, cool, but how do we really see each element in our code? Well, we have to print each element out one at a time. For small arrays, we could simply just print out number sub 0, number sub 1, number sub 2, for example. But for larger arrays, we really need a loop to do this. So let's go ahead and declare a loop control variable I. And let's do this first with a for loop, and then we'll solve it again with a while loop. So zero-based indexing, our loop control variable I, which we'll use as an index into our array, starts at 0. Now here we need to specify the size of the array. I know the array is 5 integers because I declared it as such, but it would be really good to keep track of this with an actual variable. So let's do that. let's declare a constant global variable called number size and set it to 5. Now we can use number size whenever we need to loop through the elements in numbers. I'm going to make my output really fancy here just so you can see the correlation between the index and the value. But in the future, we probably won't write output that's this long. We'll just use like a comma separated list or a space separated list. All right, number sub 0 is 4. That looks good. Sub 1 is 2. Check. Sub 2 is 7. Check. Sub 3 is 5, check, and sub 4 is -2, check. Awesome, that looks good. So that's how we can print out an array, is by using a for loop. Typically we'll declare a function or define a function called like print array that we can use over and over again whenever we need to print out the contents of our array. Very useful for debugging purposes. So now your task, resolve the for loop using a while loop. All right, looks good. Now we're ready to move on to learning about a new looping structure called a for each loop, or also known as a range-based for loop. So for each loops are really nice when iterating over items in a collection. So let's go ahead and use a for each loop in order to iterate over our numbers in our array called numbers. So it starts with for, open paren, and then we declare a variable in order to store an individual item in our array. So the data type of the variable we declare has to match the data type of the values in the array or the collection we're iterating over. So let's do int num colon numbers. And then our cout statement. But our cout statement this time is not going to make use of I because there is no I in this for loop. Instead, we can just print out num directly. All right, so how do you read this? You should read this as for each integer num in numbers. Really the key part here is the semicolon represents in or membership. We don't have a loop control variable I that actually deals with the index positions. Instead, that's all abstracted for us with the for each loop. And here we can see that num takes on each value in our numbers array. One thing to note about for each loops, if you need an index position, you could still use an I variable like we have here and just increment it inside of the body of the loop. Lastly, if you need to change a value in the array, let's say we want to add 1 to each one of our numbers here. If we were to just add 1 to num, And then let's print num back out again. We would see that num does in fact change, right? We add 1 each time. For example, 4 goes to 5, 2 goes to 3, 7 goes to 8. But it's because it's changing a local variable called num. This is a local variable to this for loop. It has a copy of the actual value at this particular position in numbers. So let me show you what I mean. Let's make a copy of this for each loop. And in between the two outputs, let's say adding 1. Okay, we add 1. So first we print it out, then we add 1. Then let's print out the array again. And see if the 1 that was added to each num was retained. So it looks like all 3 of these sets of output are identical. So adding 1 to num didn't do anything. The reason why is num is a copy, not a reference variable. We know all about reference variables now. So we can go ahead and change this code to use a reference variable. Let's make one more copy. And this time we're going to declare num to be a reference variable, not just an integer. And then we'll add 1 to num. So num is now an alias for the actual memory location in our array that stores the value of num. So if we change that value via num, then that actual variable memory location will be updated in the array. All right, so same output here, but now after adding 1, because of our reference variable, we see that in fact each one of our array elements is 1 higher. So keep that in mind if you need to use a for each loop that actually changes a location in memory. Unless you have a reference variable, that num variable is just a copy. All right, so now what we're going to do is write some code using loops in order to solve common array problems. So let's do this. Compute the average, min, and max for the values in numbers. We're going to need some extra variables in order to do this. So let's have an integer called min, an integer called max, an integer called total, and a double called average. Now, I'm going to leave this as a task for you to try. Feel free to use any of the looping structures that we've learned for, while, or our for each loop, using the variables that we just declared. I'm going to use a regular old for loop. And I'm going to first solve the average problem. All right, I'm going to accumulate the value of each element in my numbers array in a variable called total. And then I'm going to assign to average total divided by number size. The thing I'll want to note here, though, is the data type of total is integer, and the data type of number size is also integer. So this is going to give me integer division, which is not what I want. So I'm going to do a static cast and convert total to be a double before the division occurs. And then let's print out the value of average. Okay, it says average is 4.2. Looks pretty good. I'm glad to see that there is a decimal part here because we did floating point division instead of integer division here. All right, min and max. These are a little bit trickier. There are a few main ways to approach min and max problems. If your numbers are guaranteed to be in a range, like for example, let's say our numbers in our array are always in the range -100 to +100, then we could say, okay, let's assume the minimum value that we've encountered is 101. And let's say the maximum value that we've encountered is -101. So numbers just outside of our range. Then we start our for loop where we process all of the numbers in the array, looking for a value that's smaller than 101, our current minimum, or values that are greater than -101, our current maximum value. Of course, the very first element that we encounter will be smaller than 101. It has to be if it's in this range. And the very first element we encounter will also be greater than -101. It has to be if it's in this range. So that's one way of approaching the min-max problem. If you don't have a range like this, which I never specified we had for our numbers problem, then you'll want to do a slightly similar tactic, but instead of initializing min and max to numbers outside of the range, you're just going to assume the first element in the array is the current min and the current max until essentially proven otherwise by iterating through the rest of the array. So let's try this. So we're going to set min to be max, to be numbers sub 0. Now, we could start I at 1 since we've already processed 0, but I'm not going to do that because that would mess with our total accumulation. We could declare a second for loop dedicated to processing just the min and max, but that seems like a little bit of overkill. So we'll just let it be inefficient and test out to see if the first number is less than min or greater than max. It won't be because the first number is going to be min and max. So let's add the code that does this comparing the rest of the elements part. So if numbers sub I is less than min, we have a new min, set min to be numbers sub I. Then we do the same thing for greater than max. And then at the end down here, we'll print out min and max. All right, so it looks like our algorithm found min to be -1 and max to be 8. Let's just look again up here. Okay, our original array was 4, 2, 7, 5, -2. We added 1 to each of those elements, which would make the max 7 become 8 and the min -2 become -1. And here's that array with 1 added, and it looks like that is correct. So a little bit of insight as to the intuition behind this algorithm. Let's work with this array, for example. If I told you, what's the minimum value in this array, you could probably quickly look at it and say -7. How did you figure out it was -7 though? You computed an algorithm in your head in order to figure out -7 was the smallest. Step by step, and it probably happened so fast you didn't even realize you did this, you looked at each element, keeping track of what's the smallest element you've seen so far. You might have worked right to left, left to right, middle out, but you did look at each element in turn. Let's say that you explicitly start on the left side. Okay, the first number you've seen is the smallest number you've seen. So 5 is your min. And then you went to the next one and said, is this the smallest number I've seen so far? Well, it's smaller than the smallest number I've seen so far, which was 5. So this must be the new smallest number I've seen so far. Then you go to the next number. Is 2 smaller than the smallest number I've seen so far? No, it's not. Is 4 smaller than the smallest number I've seen so far? No, it's not. Is 1 smaller than the smallest number I've seen so far? No, it's not. So -7 must be the smallest number I've seen so far. If this array was larger, maybe it filled up this entire whiteboard, you would have to go through a very systematic approach, looking at each number, trying to find the smallest one. This array was so small, you might have been able to just glance at it, but really this comparing one number at a time to the smallest number you've seen so far to see if you have a new smallest number you've seen so far is the algorithm that you would likely take if you had this whole board filled with numbers. So that's the algorithm that we coded up. We assume that the first number is the smallest number, and then we check the rest of them to see, do we have a new smallest number? All right, you are doing great. We have one more algorithm to code up, and then we will wrap up our discussion of using loops to solve common array problems. Our last problem we're going to solve. Given a target value, find out where the target value is in the array, if it is in there at all. So essentially, it's a search problem. Find a target value. So let's stick with our original numbers array up here, 4, 2, 7, 5, -2. If I said, is 5 in the array, you would likely check each number, seeing, is this a 5, is this a 5, is this a 5, until you find a 5, and then you would stop looking and say, yes, I found it. You could even keep track of where you found it and say, yes, I found it, it is here. If you reach the end of this array without ever encountering a 5, then you would say, no, there's no 5 here. For example, if I said, is there a 10 in the numbers array? You would say, is 4 10? No. Is 2 10? No. 7 10? No. 5 10? No. -2 10? No. We've reached the end of the array, therefore I never found a 10. There's no 10 in here. You could work this same algorithm with this array, walking through from left to right, one at a time, doing a comparison. Is this the target value I'm looking for? Is this the target value I'm looking for? Until you find the target value you're looking for, or you reach the end of the array, meaning you didn't find it. So let's code up that algorithm. Let's declare a variable first called target. And let's set it to be 5, which is a number in the array. You'll get really used to coding up these standard for loops for iterating over each element in an array. It's going to become pretty second nature for you. This for loop is going to look just like our last one where we were using it to figure out the min, max, and average. All right, now each element we want to check. Is this the target element? If it is, we could see out and say something like found it at, and then specify the memory location. If we found it, we can break out of this for loop. There's no need to keep searching. All right, so it says found it at 0. Which makes sense because remember we added 1 to each element in our array. So our first element is actually 5. The one that was originally 5 is now 6. So if we want, we can search for 6 and we should see that it'll show up in the 0, 1, 2, 3 index position. And there it is. Now let's search for something that's not in the array, like 11. It doesn't say anything. We should add some sort of code so that when the target value is not found in the array, we give some kind of feedback to the user. Why don't you pause the video and try this task. If the target number is not in the array, tell the user. So there are a few different ways to solve this problem. My solution is going to make use of a flag variable. So I'm going to come up to the top here and declare a Boolean called found and set it to false. When we find the target in the array, I'm going to set found to true. Then outside of the loop, if found is equivalent to false, which I could also write as not found, then I could say something about the target is not in the array. And then I give the user some sort of feedback about whether the target value is in the array or not. All right, we solved a lot of problems in this video. Our main function is long. Why didn't we break this up and write functions in order to solve each one of these problems? Well, the reason why is I just haven't covered how to pass arrays into functions or what you can do with arrays once you have them in a function. But I'm going to very soon. So this is bad design, having this large for loop, having this large main function. We should break this up using top-down design. And we're going to learn about how we can work with arrays and functions